Alright, this is how to factor a quadratic. Notice it's a quadratic. It starts with an x squared. We have it in the ax squared plus bx plus c format. And it is set equal to 0, so we will be able to solve this. First step is to factor out the greatest common monomial factor. So I'm looking for anything that goes into all three terms. And so I see that 2 would go into them. And I definitely want this leading coefficient, this -4, to end up being positive. So I'm not going to take out just a 2, I'm going to take out a -2. So when I take out a -2, that turns into a 2x squared, a minus 19x, and a plus 42. Now, remember what we're going to be doing eventually is getting these all set equal to 0. I know that it can't be the -2 that equals 0 when I multiplied here and got 0. So I can leave it there when factoring it, but it won't come into my equation as an answer. So my next step is to take the leading coefficient and the constant at the end and multiply them. I get 84 when I multiply. And then I'm looking for things that multiply to get to 84, but they add to get to -19. So you can list all your factor pairs if you want, 1 and 84, 2 and 42, so on and so forth. When you start looking at them, you want them basically to add to -19, so you're going to eventually come down to the pair that works, which is -12x and -7x. -12x plus -7x will then equal, we can put a plus in between them, will then equal that -19x. You drop down the leading coefficient there, that 2x squared. Then you drop down the 42 on the end. And it's still set equal to 0, but we're going to go ahead and factor it. We factor it in two pieces, the first two together and the second two together. So what I have here is I can take out of both these, the first two, I can take out a 2 and an x. And when I take out a 2 and an x, I'm left with an x minus 6. Out of the back two, out of the -7x and the plus 42, I can take out a -7. So when I take out a -7, I'm left with an x minus 6. Now I can refactor that and say, well, out of this piece and this piece, I can take out an x minus 6. When I take out an x minus 6, I'm left with, on this side over here, when I divide it out, I'm left with a 2x. On this side over here, I'm left with a minus 7. Now we can bring down everything else. That would be a -2. It does still equal 0. Okay? Remembering that I can always look back and check this by doing the FOIL. So I'm going to redo the FOIL in just a moment. Shrink it down a little bit here. So I'm going to use that x minus 7 and 2x minus 7 and use FOIL. So if I do FOIL, I'm going to get, when I take my first, I'm going to get 2x squared. When I do my outers, I'm going to get -7x. When I do my inners, I'm going to get -12x. When I do my last, I'm going to get 42. When I combine my like terms here, I'm going to get 2x squared minus 19x plus 42. And that's exactly where we wanted to be because that's where it was when we started factoring it right back here. Okay? So it does work out with FOIL. It's a good way to check your work in the middle of the process. And so now we go back to this step right here and we say, you know what? If I multiplied A times B times C and I got 0, then either A is 0, B is 0, C is 0, or all or any two of those are 0. So we know that it can't be the -2 because -2 cannot equal 0. So I want to solve by setting x minus 6 equal to 0 and then solving. Of course, I would add 6 to both sides to solve that. And I get x equals 6. And then I'm going to set 2x minus 7 equal to 0. And then, of course, I would add 7 and then divide by 2. And I'm going to get x equals 7 halves. So our zeros are x equals 6 and x equals 7 halves. To review what that means, of course, we'll shrink that down a little bit more. We know that this would be a parabola if we graphed it because it's a quadratic. If we looked at it, we would say since the leading coefficient is negative, it's going to be opening down. Remember what your zeros are. Your zeros are the place where it hits the x-axis. It hits the x-axis at +6, somewhere out in there, and 7/2, which of course is equal to 3.5, somewhere in here. You would then know a couple of extra things. You would know that the axis of symmetry would be directly in between those points. You also could look back at it and find your y-intercept if you wanted to look back that far. Of course, it's going to be low at -84. And then you could graph it. Of course, if you wanted to find its vertex exactly, you would go back to the thing and put in your opposite b over 2a, which would get you your x coordinate. And then you would plug that answer back in as your x, solve it for your y, and you would have your vertex for your parabola.